Okay, chapter 4, we're going to be talking about equations. Wrong button, sorry. We're going to be talking about equations. And prior to this, we were talking about expressions. So we're going from expressions to equations. And if you look at the word equation, you see the root word equa, which is close to, hopefully you're realizing, equals. Okay, so the difference between an expression and an equation is that we have there's an equal sign in equations. So if you remember from expressions, we were simplifying expressions, right? And that was combining like terms, and combining like terms was addition and subtraction. We learned about distributive property, right, which was multiplication, and we learned about factoring. Sorry, running out of room here. Factoring, which was basically division. Okay, so in simplifying expressions, we were basically just with expressions, we were just simplifying them. So we might have had something that looked something like this, which is an expression. This is a simplified expression because I can't add anything together. There's no distributive property, and it's not asking me to factor this expression. But an equation is going to end up having this equal sign, and it will and then it will be equal to something. And what we're going to try to do in this chapter is solve for the variable. Okay, so there is a specific number that when I multiply it by 2 and add 1 to it, I get 20. Okay, and we'll learn how to solve that. But first of all, you might want to, if you want to take a screenshot, you can. Otherwise, I'm going to be erasing everything here, just so I can make a point of what they're talking about here with these, with some of this vocabulary. Okay, I know vocabulary isn't the most exciting, but I do need to teach it to you. So equivalent equations occur when basically you can say that you will come to the same conclusion. In other words, that 2x plus 1 equals 20. If I can do something to that equation where I'm going to get the same value of x, then it is said to be equivalent. Let me give you just an example. So if I have, what they're trying to say is here, that if a equals b, then if I add something to it, to a, and add the same something to the other side of the equation, then they will stay equal. The subtraction property says if I have a equal to b, and I subtract something from it, the same something from both sides, it will remain equal. Let me show you what that means. Okay, so if I have 5 equals 5, okay, that is true, okay? So both sides of my equation are equal. Now if I add 3 to one side, I get 8, and 8 no longer equals 5, okay? But if I add 3 to both sides, then it remains equal. And that's kind of what we're going to be doing. Also, if I subtract 4 from both sides, right? So if I subtract the same number from both sides, it maintains its equality, okay? So let's, oh, wrong button. All right, so let's just look at what this does. Okay, notice here addition and subtraction, this is key, are inverse operations, okay? So that's basically what we're going to be doing for the next couple sections, is we're going to look at what we have, and we're going to be doing the inverse operation. Let me show you what that means. Okay, so solve x minus 5 is equal to -1. And I just want to encourage you that even if you know what x is just off the top of your head, get in the habit of doing these properly. So the way I'm going to do it is I'm going to rewrite my problem as always. And some people like to draw a line through the equal sign because we're going to keep our equal signs lined up. And whatever I do on the left side of this line, I have to do on the right side. That is basically the golden rule of algebra. Do unto one side of the equation what you do unto the other. Okay? So now I am solving for this x. So the first thing I do is I want to get x by itself. I don't want the thing getting in my way. If I could just erase it, would be if I could just erase this -5, then I would have x. But I can't just erase it. That's not mathematically correct. So what I need to do is the inverse operation. Because an inverse operation basically undoes or makes, turns this -5 or -5 into a 0. Okay, so let's do that. So if we add 5 to this side, the opposite of -5, or the opposite, it's better to think of it as the opposite of -5. Okay, then I have to do the same thing on both sides. -5 plus 5 equals 0, or I can just cross them out. And then the only thing left is this x, and that's what I want, and I'm keeping my equal signs on the line. And now +5 and -1, right? That's where I have to sing the song, okay? Now you guys have to focus on these because it's not as simple. It especially gets more difficult when we have fractions. So now I have different signs, so I subtract and keep the sign of the bigger number, then I'll be exact. 5 and 1 are different signs, so I'm going to subtract. 5 minus 1 is 4, and I keep the sign of the bigger number, which is positive. And now I can even check these, which is super cool. So instead of x, I have 4 minus 5 equals -1. Well, these two different signs subtract, keep the sign of the bigger number, and -1 does equal -1, so I can check and say that is true. Okay, so let's look at this next one. We're gonna, as always, and I highly recommend putting lines through your z's. For one, you're now officially cooler, and for two, it keeps you from mistaking your z's and your 2's, right? So z and 2 can look very much alike, especially if you're writing quickly, as you can tell. But if I put that line through it, all of a sudden it's very clear that that's a z. Okay, so anyway, z plus 3/2 is equal to 1/2. Okay, draw your line, if that helps you keep it organized. And now I need to get rid of this positive 3/2 so that I have my z by itself. So the opposite of positive 3/2 is negative 3/2 or minus 3/2, however you want to look at it. Either way, it's going to become 0. And now when I'm dealing with fractions, I'm going to go ahead and put minus 3/2 right next to it because it helps my brain to process it. It's like a horizontal thing. Okay, I need a common denominator, which I have. So since I have a common denominator, I do not need to get it. So now different signs subtract. 3 minus 2 is 2. So this equals 2 over 2, and keep the sign of the bigger number, which is negative. So negative 2 over 2, hopefully you recognize by now that 2 over 2, or anything over itself, is simply 1. Okay? And -1 plus 3.5. Okay, so we would have to put negative 2 over 2, which is the same thing, plus 3 over 2, I'm just using common denominators, is equal to 1/2. Different signs subtract, keep the sign of the bigger number, then you'll be exact. So 3 minus 2 is 1. Keeping the sign of the bigger number, 1/2 equals 1/2, so I can officially check that as correct as well. All right. So, I want you to go ahead and pause the video if you want, and see if you can get these 3 correct. Okay, so I'm going to do this as if it were my homework, okay? I'm going to do number 1, I'm going to start by writing the equation down. Please write the problems down. It's so helpful. I'm going to draw my line. I'm going to add 5 to both sides because it is the inverse operation of -5. That is going to make this a 0, and P will be equal to this. That's a terrible bracket thingy, but anyway. Different signs subtract. Keep the sign of the bigger number, then I'll be exact. And now I'm going to plug it in. 3 minus 5 is equal to -2. Different sign subtract. Keep the sign of the bigger number, then I'll be exact, and that's a check. All right, number 2. W plus 13.2 is equal to 10.4. Okay, so I'm looking here. I'm trying to get W. I need to therefore I want W by itself, so I have to get rid of this 13.2. So a -13.2 ought to do it. Don't forget my line here. That helps us keep organized. And now I have to do 13.2 minus 13.2 on the other side. Remember, golden rule of algebra. These go away. W, therefore, is equal to 10.4 positive minus 13.2. Now, different signs, right? This is a positive, this is a negative. Different signs subtract. Keep the sign of the bigger number, then I'll be exact. So now I'm going to come over here and I actually have to put the greater value on top. Don't forget. And I have to line up my decimals. So now I'm going to do that, and I get 8 and 2. So I get 2.8. And keep the sign of the bigger number, then I'll be exact. Okay? And -2.8 plus 13.2. Does that equal 10.4? I could even put this in my calculator if I wanted to. But this would be different signs, subtract, and I do get 10.4. And like I said, that would be okay time to use your calculator once you've done it without. Okay, let's see. I can't move this screen, unfortunately, so if I had another piece of paper, I would grab it, but since I don't, let's come down here and do number 3. X minus 5/6 is equal to -1/6. Draw my line. I'm going to add the 5/6 to both sides. Actually, I'm going to, I always do that. I'm going to add my 5/6, but I'm going to do it to the side because it's a fraction. And for me, it helps my brain work. These go away. X is equal to -1/6 plus 5/6. Again, I have a common denominator. Different signs subtract, so this will equal 4/6. Keep the sign of the bigger number, which is 5/6, but this 4/6 needs to be simplified. So that'll be 2/3. So x equals 2/3. And then I could put this in my calculator and double check it, but that is correct. All right, that's it. So this is adding and subtracting. The only thing you'll have to do on top of this will be solve story problems. The whole point of the story problem is it's going to create a simple thing where you don't know one value, but you know 2 other values, and you're just going to need to set up the equation. So we can work on that in class. Maybe we'll do a story problem in class. So anyway, if you have questions, let me know. Thanks.